We talked a little bit about bisectors when we were doing segment and when we were doing angles, but this actually defines it, and we're going to do some construction with the bisectors. So the first thing, recall that M is the midpoint of AB. If M is between A and B, that's what that means. So M is between A and B. And AM equals MB, meaning it divides it in two congruent segments, which it defines that word there as well. The distance between the endpoints of the segment is measured to twice, really, that of the midpoint. So this entire segment should be exactly double one of them. And that's actually what this next theorem tells you. All right, this next theorem tells you, the midpoint theorem says, if M is the midpoint of A and B, then AM is equal to 1/2. So let's look at this example that they gave us. Find the coordinate of T if the coordinate of M, the midpoint, is 2 and the coordinate of R is 5. So they've given us almost like a number line setting here. All right, so they're actually telling us that we have this line segment here, all right, from R to T. And they want us to find the coordinate of T, the endpoint, all right? The midpoint is 2. So what does that tell me? The midpoint 2 is exactly the same distance from each side because it's the middle. They also gave me R, and I think they wrote it backwards here. So they wrote it with T and then R, or I wrote it backwards rather. So let's do this so it makes sense on the number line. All right, so they have R and they have T. I did it again. They have T and they have R. All right, R is 5. If this is the midpoint, how far away is it from the endpoint? Logically, how far away is that? 3. If it's the midpoint, it should be the same exact distance over here, right? This should also be 3. How far away, what number is going to be over here if that's 3 on a number line? This is a number line. -1. All right? So they're just asking for the other endpoints. They're the same distance. So that's all midpoint is. Midpoint is exactly the same distance from either endpoint. That's all they're telling you there. All right? And that's what you should also know is the total distance then from here to here should be exactly double this. And it is. From -1 to 5 is 6, which is exactly double what the midpoint was. That's how it will always work for midpoint because it cuts it in half. This theorem tells us right here. That's all it's telling us. If it's the midpoint, then half of it is going to be halfway through. So the length of that little piece is going to be exactly half of the total length. All right, look at the next one. They've thrown in some algebra into it. Find the coordinate of the midpoint M if PQ, if P is -15 and Q is 7, then use the midpoint theorem to verify. All right, so they have told us that P is -15 and Q is 7. So if they want to know the midpoint, we have to figure out how long the segment is so we know how far away it is from each side. So how do I find out how long it is? Well, I need to find out how far apart the endpoints are. All right, I have some segment here from P to Q. All right, P is -15, Q is 7. How do I find out how far apart those are? What am I going to do? Yeah, I'm going to subtract them, right? -15 minus 7 divided by 2. Now, when I'm talking about distance, you're actually going to do this, okay? You're going to do an absolute value there. So what's -15 minus 7? Yeah, it's -22, right? Well, an absolute value there. So I have, what's that going to be? 22 over 2 is going to be 11. All right, 11. All right, so that means the midpoint should be exactly 11 away from this guy and exactly 11 away from that guy. So where's my midpoint? It's at -4. Now, the formula they use is that you actually just add the two numbers and divide by 2. And so let's see if that works. So if I just add these two up and divide by 2, will I get -4? Well, -15, add the 7, divided by 2. What's that going to be? -8 over 2, which is the exact location of the midpoint. All right. So if you're looking for location, you can just add up the 2 on the number line and divide. And we're actually going to do this next chapter on a coordinate plane. If you are looking for the distance away, you're going to have to implement the absolute value and add or subtract the distance depending on which way you're going. All right, so that is midpoint. Midpoint's going to be exactly halfway in between the 2. All right, so try some of these on page 100, 3 through 5, and then we're going to do some construction. Find the coordinate of the midpoint of FH, all right? So they first wanted from F to H, and they wanted that midpoint. F is at 4, H is at 10. So you should have gotten 7. 7 there. The next one they wanted the coordinate of the midpoint for CE. C to E. C was -6. E was 0, so you should have gotten -3 there. And then what point is the midpoint of C to G? So from C to G, -6 to +6, the coordinate was E. They wanted the coordinate. When they say coordinate, they actually want you to label it, the label, not the number. So they wanted E there. A segment bisector. A segment bisector intersects a segment only at its midpoint. All right, so the term bisector, this is something you may see in a proof. They'll say, this segment bisects that segment. And what they're telling you by saying that is definition of a bisector means that it crosses it in the midpoint. So if they said this bisects that, you could say then it crosses at the midpoint. That's definition of bisector. And then you could say these 2 parts are equal. That's definition of midpoint. And so the bisector definition crosses at the midpoint. That's what it tells you. This can happen with a line, a ray, a segment, or a plane. And if it forms right angles, then it is called the perpendicular bisector specifically. So bisectors can cross at the midpoint at any angle, but if it does at right angles, it's called a perpendicular bisector. Perpendicular bisector. So this is the first construction that we're going to do. The very first construction is a perpendicular bisector. Look at construction number 4. Perpendicular bisector of a segment. For the perpendicular bisector, you want to start with your line. You are then going to place your compass point at one end of the line here and stretch the compass out till it looks like you're more than halfway across. It doesn't matter how far, just don't go past the end point. Make sure if you just were to look at it, because all you're going to have is this line right here, that you're going to stretch it out, and then you're going to draw this first arc here. And then once you draw your first arc, you're going to keep your compass the same, bring your point from the end to the other end. So now your compass point should be over here at the other end. Same arc, you're just going to draw it on the other side. So now you have 2 arcs that intersect here at the top and at the bottom. And you are going to take your straight edge and you are going to join those 2 points. And you're going to join them, it will form right angles at the midpoint. So it tells you that you have cut this original segment in half at this midpoint here. It will also tell you this is a right angle and that these 2 are congruent. YZ. So an angle bisector then is a bisector if the ray itself falls inside the angle and it creates 2 congruent angles. So angle 1 is congruent to angle 2, or the measure of angle 1 equals the measure of angle 2. All right? Once again, with angle bisector, we have this theorem. If it bisects the angle, then the measure of one of the interior angles should be exactly half the measure of the whole angle. That makes sense. Let's look at the figure itself. Number 25, because they didn't give us an example here. So number 25 in your books, use the figure to find each value. And then they have told us this definition right here. It says then that UW bisects TUV. So what did that tell us then? Well, that tells us that this angle is congruent to that angle. If we know they're congruent, what do? Well, we can just set them equal to each other. 2x minus 5 equals 3x minus 22. All right? And so how do I solve this? Move your variables to one side, numbers to the other. So I'm going to move my 3x over. and I'm going to move my 5 over. All right, we get negative x equals negative 17. And then you then, of course, have to divide by negative 1. So we have x equals 17. All right, so we know that one. What else do they want? They want TUW. TUW. Well, how do I solve for that? How do I solve for TUW if I know what x is? Just plug it in, right? So TUW is 2x minus 5. So 2 times 17 minus 5, right? 34 minus 5. TUW is going to be 29 degrees. The next one they ask for is TUV. Do I need to plug this in? Do I need to plug it in to solve? I know this is the bisector and I know half of it. What's the only thing I have to do to find the whole? Yeah, just add them up. 29 and 29, right? If the half is 29, the whole is going to be 2 of that. So that should be 58. All right? You could plug it in, but you're going to get 29 for the other one as well. All right? So they just want you to know that bisecting means to cut it in half. Bisecting means to cut it in half. All right? So try 26 on page 101. Try 26. Instead of using the word bisector, by the way, they used notation. So instead of using bisector, they used a notation here. All right? The notation they used here was these little symbols, which tell you they're congruent. So they told you using notation that this is the bisector. They told you using notation that that's the bisector. And then you're also going to have to use some linear. X. If I know those are congruent, what am I going to do to solve for x then? Set them equal to each other, right? They're congruent. So then they equal each other, right? Move your variables to one side, numbers to the other. All right. 7 plus 29, you should have gotten 36. 8 minus 5, 3x. So x equaled what? 12. All right. Then they wanted you to solve for specific angles. The first angle was DBC. So we have angle DBC. For that one, just plug it in. We have x equals 12. Plug in a 12 for the x. 8 times 12 minus your 29. You should have gotten 67 there. All right. Now what that told you is this is 67 degrees, but so is this one. All right. They're congruent. So then the next one they wanted you to solve was ABE. How am I going to solve it? What should all three equal? 180. Why do I know that? Well, all three together form a line. It's not technically a linear pair because pair by definition is 2. But all three of them together do form a line. So you should have said 180 minus the 2 other angles. All right. And then when you did that, you should have gotten 46 degrees there. 46 degrees. For bisecting an angle, you're going to start off having given an angle. So this red angle is what you will be given. And the question is, will you bisect it? So what they're wanting you to do is to bisect this angle. So you're going to set the point of your compass right here at the vertex of the angle. And then you're just going to stretch it out. It doesn't matter how long you stretch it out. I stretched it out to here. And you're going to draw an arc. And so you're going to draw this green arc. And then you're going to put your compass point where it crossed the angle up here. Don't change the width of your compass and draw another arc out here. Do the same thing down here. Point of your compass here, same length and same width that you had the compass pulled out to. Draw this arc here. And the 2 arcs should intersect. If they don't, you might need to draw them just longer. They're going to intersect. Then you are going to draw a line from the vertex of the angle to where those 2 arcs intersected. And that's where we get this yellow line here. This yellow line represents the bisector of the angle, which tells you that the smaller 2 angles are congruent.